righty, folks. Hello, hello, hello. So today we're gonna start going into the second part of Unit 2. We call it Chapter 2B. And we're gonna go back and look at some stuff we would have done in Algebra 2 and as well as potentially Algebra 1. Things we didn't get to because of the COVID stuff, but we want to fill in. At the same time, it's a huge thing that will come up when we get to trigonometry and we're looking at trig proofs and simplifying trig expressions, as well as when you get to AP Calculus, exponents and fractions play a huge part of what we're looking at and what we end up doing. So we're going to spend just a couple days just going over some of the things we would have possibly looked at as far as rational expressions go, and then we'll eventually work our way into rational functions. So I'd begin with just adding and subtracting rational functions. So when we're dealing with these guys, one of the big things we always got to make sure we do, just like with any fraction, so like say 2/3 plus 3/5, we have to make sure that we always get them over a common denominator. So one of the easiest ways to do that is just look at the other denominator and multiply the top and the bottom by that same denominator. So essentially we're multiplying by 1. And if I multiply any fraction by 1, it's still the same fraction. So, and that would have given us 10/15 plus 9/15. And we then would go ahead and add the numerators and call it a day. So we would end up and get 19/15, just to finish that off there. But with rational expressions, it's the same thing. The first thing we want to always do is factor each denominator so we can try to figure out what factors are currently missing. After that, we're going to multiply both the top and the bottom by whatever factor is missing. So I notice that underneath x is x minus 3. So I'm going to multiply this fraction right here by x minus 3. This one is under x plus 4. Well, I'm missing an x plus 4 here, so I'm going to add it to this side. Well, not really add, I'm multiplying it to this side. But notice, I multiply the top and the bottom by it, so that way I'm over a common denominator. Because once I'm over a common denominator, just like with the 10/15 and 9/15, I can write them together. So I didn't have to actually write these as two separate fractions. I could have wrote them when I put them together as 10 plus 9 over the common denominator. And that's essentially what I'm going to do here. Since now I have x minus 3 times x plus 4 in both denominators, I'm going to combine them as one fraction. So we're combining them as one fraction. And they're all over x minus 3, x plus 4. So now, once we have them over that common denominator, now we're just going to go ahead and simplify the numerator. And when we're done simplifying, if we can factor, we're going to go ahead and factor. If it doesn't factor, we'll leave it alone. So I have 5x minus 15 plus x squared plus 4x. So we're just cleaning up that numerator a little bit. And when I combine my like terms, I get x squared plus 9x minus 15 all over x minus 3x plus 4. Now, if I can, I'm going to look for a common factor that I can cancel out of both top and bottom to simplify this fraction even further. However, x squared plus 9x minus 15 doesn't factor. So in this case, I'd be done. That'd be it. So once you guys do me a favor, go and pause the video and see if you guys can go through and subtract the next fraction. All right, well, let's see how you guys did. First up, I'm hoping that you guys factored at the beginning. And when we factor it, we end up with x minus 3, x plus 2 minus 2 times x plus 2 and x minus 2. So again, we're looking to see what factor is missing. In this case, I notice that x minus 2 is right here. I don't have an x minus 2 over here, so I'm going to multiply top and bottom by x minus 2. Whatever factor is missing, that's what I'm going to multiply top and bottom by. And then over here on this one, I'm noticing that I'm missing an x. I have an x minus 3, but I don't have it over here. So I'm going to multiply this one by x minus 3. I multiplied top and bottom by it. So now I got a common denominator. I can go ahead and clean this up here. So I got x squared minus 2x. And by the way, just for the sake of argument, when I go ahead and I distribute this, I'm going to go ahead and make this a negative 2, a plus a negative 2. Just helps me with the multiplying. So minus 2x. And then I'm going to have a, let's see here. I got x squared minus 2x, and I got a negative 2x plus 6. All right. Just like that. And they're all over that common denominator. So that gives us then x squared minus 4x plus 6 all over x plus 2, x minus 2, x minus 3. And again, the numerator, I check to see if it factors. It won't factor, so I can go ahead and leave this as my final answer. So hopefully we're doing okay so far. I want you guys try these two and see what you can come up with. All right, go ahead and pause the video, try them both, and then we'll take a look at it. All right, here we go. We got x plus 1. All over x minus 4x plus 2. And I'm going to subtract x over 2 times x minus 4. And again, we're looking to see what is missing. Now, notice I'm not necessarily missing a factor. I'm just missing constant. So I'm going to multiply the top and bottom by that constant. So multiply by 2 over 2. This one is missing an x plus 2. So I'm going to multiply this one by x plus 2. And again, I'm going to distribute that negative in there. Be careful also when you distribute your 2 in there. Remember that this is technically in parentheses. So that 2's got to go into everything. So what do we have here? We have 2x plus 2 minus x squared minus 2x all over 2 times x minus 4, x plus 2. And what do we got here? That gives us a negative x squared plus 2. And then we have 2 times x plus 2x minus 4. And I can factor out a -1 on top. It's not going to do anything really for me, but still, I'll still factor it out, because if we can factor, we really want to factor, just to see if there's anything that could potentially cross off both top and bottom. In this case, there is none. So I'm going to leave my final answer alone. All right, let's try this one here. You guys already did this, so let me see if I can catch up to y'all. I have an x over x plus 2, x minus 2. There we are. And on this one, I have a 2x plus 1 all over x plus 2, x plus 3. Got to find whatever common factor is missing here. So let's see, I'm missing an x plus 3, so I'm going to multiply top and bottom by x plus 3. So again, what we're really multiplying by is 1. Just getting a common factor. And on this one, I'm missing a, let's see, I'm missing that, looks like that x minus 2. So I'm going to multiply top and bottom here by x minus 2. All right, now we multiply it all the way out. So what do we have here? X squared plus 3x. Ooh, and then that next one here, that's what, 2x squared. And you guys would be using your generic rectangles here to multiply it all the way out there. I'm going to go ahead and FOIL it, though. So these are the 4 terms you would have found in your box there. So if you did it correctly, you're going to end up with 3x squared. The 3x, 4x, the x's go away. That's kind of different. And then I'm left with a minus 2. Well, that doesn't factor, so I can leave this alone. My final answer. So the first thing you're going to be doing today is you're going to be combining rational expressions by adding and subtracting. So again, just quick review of just some Algebra 1 concepts, Algebra 2 concepts, to make sure that we are all on the same page, because we will use those a lot in pre-cal and calculus. And then at the same time, it's going to be on your SATs as well. So I want to make sure we get all those taken care of. All right, let's keep going here. The next part is solving a rational equation. So the first thing we always start off with, and I don't have it down here, but the first thing we always start off with, we want to look at every factor. Every factor in our denominator, and remember that every factor in the denominator cannot be equal to 0. So when I go through and I solve this thing, I need to remember that x can't be equal to 0. Okay? So the first part, then factor all my denominators, well, they're factored. And I'm going to multiply each term by the common denominator. So in other words, I'm going to multiply each term by the common denominator. So if my fraction is 2 over x plus x over 3 equals 5 over 3, I'm going to multiply every fraction by the common denominator. So in my denominator right now, what I have is I have an x and I have a 3. So I'm going to multiply every fraction by 3x, or 3x over 1 if you really want to get really technical. So this is technically 3x over 1. So I'm going to multiply everything by 3x, because on an equation, whatever you do to one side, you do to the other. Notice what happens here. my x's would cancel out here. My 3's cancel out here. And my 3's would cancel out here. And I'd be left with 3 times 2, which is 6, plus x squared equals 5x. Well, now I'm down to solving a quadratic. So x squared minus 5x plus 6 equals 0. And I'm going to go through and I factored here x minus 2, x minus 3. At this point in time, I'm assuming you guys are getting pretty good at factoring. Either you're using your box of diamonds or whatever, but when you factor it, that's what you come up with. And you end up with x equals 2 and x equals 3. So here's where we come back on this part 4. It says check to see if any of the solutions are extraneous. What an extraneous solution is if you plug it back in and you find out the answer doesn't really work. Or in our case, if I plug it back in and I notice that it's going to make my x value equal to 0. That happens sometimes. If that happens, then I have to cancel out that problem. So I look at this first one, x equals 2. Well, that would work here because I said before the only answer that x can't be is 0. So x equals 2 is just fine. I look at my next one, x equals 3. Again, if I plug it back in, it didn't make my x equal into a denominator of 0, so I'm okay here. So let's see if we can't try this together then, all right? So here's what I want you guys to do. So I want you to go ahead and pause the video, and I want you to see if you can actually figure out what values x can't be. Let's just do the first part. What values can x not be equal to? So go ahead and factor your denominator and tell me what x can't be equal to. All right, you ready? Let's see how you did. What values can x not be equal to? So we're going to go through and we factor everything. I see that I have an x minus 1 in my denominator, x minus 2 in my denominator, and if I factor this other factor here, this other quadratic, I get x minus 2, and I get x minus 1. So I have two factors in. Therefore, those are the factors I'm going to use to tell me what x can't be equal to. So x minus 1 cannot be equal to 0. That means x can't be equal to 1. X minus 2 can't be equal to 0. That means x can't be equal to 2. So as we go through and figure this out, I need to remember when I get to the end, my answers cannot be 1 or 2. So if I'm multiplying by my greatest common denominator, that means I'd be multiplying by x minus 1 and x minus 2. I'm going to multiply every fraction by x minus 1 and x minus 2. Multiply this fraction by x minus 1, x minus 2. And I'm going to multiply this fraction by x minus 1. Every fraction will get multiplied by that common denominator. And we're going to now cross off whatever factors are the same. So x minus 1, I have that one right here. So those are gone. X minus 2 is going to go away. And notice this one already had both of them, so I'm going to get rid of those as well. So what I'm left with is x times x minus 2 minus 1 times x minus 1 equals negative 2x minus 1. So x squared. We used to call these back in Algebra 1, we called them fraction busters because you're busting up the fractions, getting rid of them, so that way we can solve them all the way down. That was back before the we were doing integrated math. All righty. Now, I shouldn't have those equal signs in front. We keep simplifying here. I get x squared minus 3x plus 1 equals negative 2x minus 1. So we're going to get one side equal to 0. So x squared minus x plus 2 equals 0. So we have x minus 2. We have x minus 1. So x equals 2. And we have x equals 1. So when we go through and we are finishing this up here. Oh, did I make a mistake? I did make a mistake. I meant to make that a minus 2. So that's all right though. Let's make sure I didn't make an algebra mistake earlier. When I originally wrote this problem, I meant to make that a minus 2. Yep, we're good. So this one doesn't factor. So we're going to use our quadratic formula here. So x equals a negative b. So a negative negative 1. That makes that a positive 1. Plus or minus the square root 1 minus 4 times a times c minus 4 times a times c, which would be 8, all over 2a. And we end up with x being equal to 1 plus or minus I root 7 divided by 2. So if they asked for what real number would work, we'd say no solution. But we do have an imaginary solution here, although we're not really playing with imaginaries in general. This would have had an imaginary solution. All right, friends, why don't you pause the video and see if you can't try the one below it, all right? Try the one below it. Go for it. All right, let's see how you did here. We have x plus 2 over x plus 3. Plus x plus 1 over x plus 2 equals x squared plus 10x plus 15. That's a weird. All over x plus 2 and x plus 3. And again, we're dealing with two factors. So I got to remember that based off these two factors, this can't be equal to 0 because I can't have 0 in the denominator. And x plus 3 can't be equal to 0 because I can't have 0 in the denominator. So when I get all the way done with this problem, I cannot have x equal to negative 2. And I cannot have x equal to negative 3. So when I get done solving this, I got to make sure that those are values that I do not have. So I'm going to multiply top and bottom here by, let's see here, x plus 2, x plus 3. So everything is going to get multiplied by that common denominator. This one's also going to be multiplied by x plus 2, x plus 3. And this one right here will also be multiplied by x plus 2. Make that a little higher. There we go. X plus 2 and x plus 3. And then, just like before, cancel out the values, the factors that they have in common. So gone and gone. Let's see here, gone and gone. And whoop, whoop, they're all gone. So we end up with x plus 2 times x plus 2. Over here, we'd have an x plus 3 times x plus 1. And then right here, we'd have x squared plus 10x plus 15. So x squared plus 4x plus 4. Multiplying all these out now. X squared plus 4x plus 3 equals x squared plus 10x plus 15. So 2x squared plus 8x plus 7. So we're combining our like terms on the left side. And now we're going to take the x squared plus 10x plus 15, and we're going to subtract it over to the other side to make a quadratic equal to 0. So x squared minus 2x minus 8. And then we factor. I'm sure you guys either grouped it or you did your box and diamond. Some of you are at the point now you're doing them in your head. That works too. All right, so that means we have x equals 4. And we have x equals -2. So we're going to take a look at our factors real quick. X equals 4. Was that one of these two up here? Was it one of our original values that we said we could not have? So we're looking at x equals -2, x equals -3. X equals 4 is okay. We can have that one. What about x equals -2? Oh, wait a second. That was this one. We can't have that one. So it turns out that one is a bad answer. So we can't have that one. That means we have to exclude it. So our only answer here then would be x equals 4. So that means that this one right here, we'd say that that is an extraneous solution. X equals -2 is an extraneous solution. Doesn't work. Wish it did, but it doesn't, because it was one of our values that made our denominator equal to 0. So we toss it. So that means I only have one answer to my problem. So the only answer I get to use is x equals 4. That's the only answer to my problem. I had to toss that x equals -2 because it was extraneous. All righty, friends. So that'll walk us through a little bit here. We're going to take a look at more rational expressions tomorrow. So why don't you guys go ahead and log off, and I'll look forward to seeing you guys in the morning. All right, take care.